Well, welcome everybody. Welcome to Analyzing Streaming Data in Real Time with Amazon Kinesis Analytics. Realize that could be the last session you have today before you make your way over to the welcome reception. So I appreciate you spending some time here this afternoon with me to learn a little bit about what we've got going with Kinesis Analytics. So before we kind of dive into the details, let's just take a quick look at what we'll discuss over the next 45 minutes or so. We'll take a look at just a streaming data overview, just kind of get a good idea, to kind of level set some context for streaming data and why Kinesis Analytics is important in that space. Then we'll do an Amazon Kinesis platform overview. If you're not familiar with the Amazon Kinesis suite of products, it's more than just Kinesis Analytics. So we'll talk a little bit about the entire platform, and then we'll move right along and get into Kinesis Analytics overview, and we'll dive a bit deeper into that. We'll talk a bit about Kinesis Analytics patterns, what we've been seeing from customers who are using it today in the real world in production. And then we're going to do a walkthrough to kind of help you understand Kinesis Analytics, how you might be able to build your own application using Kinesis Analytics. We're going to walk through a fictitious scenario, but it's a real-world scenario, and so that should give you some good insights into how you might be able to leverage this with your own data. And then finally, no reInvent talk is complete without a discussion of best practices for any given service. So we'll talk a little bit about some Kinesis Analytics best practices. So a quick show of hands, maybe. How many folks in here are already processing data in real time, doing some real-time streaming data analysis? Cool, maybe about a quarter of the room, so that's awesome. So you're probably familiar with a few of these things that we're about to discuss, but I think it's important. So most data today is produced continuously, whether that be from a mobile app, maybe it's a web log, an Apache Access log perhaps, application logs that are going to be unique to your application, IoT sensors. All of these things are producing data at a lightning pace, and that's because of the prevalence of real-time data sources. They're creating the data extremely fast, and it gives us and you all insight into what your customers or your organization is doing right now. So it's really important. But what is that data worth? How can you extract value from that data? Recent data is extremely valuable, but only if you can act on it in time. Old plus recent data is more valuable if you have the means to combine them. So what we're looking at here, this chart, it's from a really good white paper called Perishable Insights, created by Forrester. What's interesting about the white paper is they discuss exactly what I described as the value of data, if you can act on it immediately, is immensely more valuable than if you wait for a significant amount of time, maybe days or weeks, to process the data. A couple of examples. Think of a business report that maybe your business has created last year, right? It's not, if you pull it up today, it might still be sort of interesting to look at, but there's not a ton of value, not as much value in that report as in the report that might have been created yesterday. So that's kind of a long-term view. Think about machine data or error log data. If you look at that error log data from a month ago, a year ago, it probably has some value, but not as interesting as an error log right now. So it gives you some good insight into why real-time current data is important. But processing it as it arrives is difficult, right? It requires a special skill set. A lot of times you have to either hire developers with a new skill set. You have to train developers to do this. Then they have to go implement it. It might take weeks or months for them to implement the solution and build a robust infrastructure to do it. So the fact of the matter is, a lot of people who start down this path, they generally don't get all the way to real-time streaming processing. They typically kind of go with the status quo. They're like, okay, I'm good with the batch process. I'll run nightly or hourly or weekly ETL jobs, and I'll run my process because it's just too difficult to do it in real time. You need a different set of tools to collect and analyze real-time data. With traditional analytics and processing the data at rest, data would come in, you'd persist it in a database, you'd write a query, and then, like I said a moment ago, you might be fine with getting that data tomorrow or next week, but that doesn't give you the immediate insights that you might want for your business. An real-time analysis system is different. It needs to be able to process that data as it comes through the system. Also, the data is coming at an extremely fast pace and a very variable rate. A lot of times this data is going to kind of burst through the system depending on what your systems are doing, and then maybe shrink back down again overnight in that kind of a scenario. So a streaming analysis system needs to be able to process this data as it flows through the system before it lands in a durable storage location. Some of the key requirements for building a stream processing system is that it needs to be durable. When a message gets written to a streaming data system, you want to make sure that you're confident in that when the data was written, it's written durably and you're not going to lose that data. It needs to be continuous. This is streaming data. The system needs to be able to process the data as it goes through. It needs to be fast. A lot of times you may decide that you want to process that data sub-second. If your streaming data can't keep up, if your streaming data platform can't keep up with it, then you're losing the real-time value. Of course, it needs to be correct. So at least once processing, only once processing. These are semantics that are important in a real-time streaming processing system. You need to make sure that the data arrives in the destination and that it's accurate when it gets there. It needs to be reactive. You need, as a business, you are going to react to this data. If you're processing real-time streaming data, you're doing it for a reason. You want to react quickly to something that's going on in your environment or something that's happening in your business. So the system needs to be able to give you the ability to react to that data quickly. And it needs to be reliable. It needs to be highly available. It needs to do fast failover in the event that there's some kind of an issue. And you want to be sure that it's able to handle that and that your data is flowing through and that it's available to you and to the downstream systems from your real-time ingestion platform. So let's take a look at Kinesis, how you can build a real-time streaming data platform using the suite of Amazon Kinesis products. So as I mentioned, Amazon Kinesis comprises of 3 different products today. We've got Amazon Kinesis Streams, Amazon Kinesis Firehose, and Amazon Kinesis Analytics. We're going to touch briefly on Kinesis Streams and Kinesis Firehose, and then we'll get into Kinesis Analytics in a bit more depth. The reason we need to talk about Kinesis Streams and Kinesis Firehose is because they are a requirement to use Kinesis Analytics. So Kinesis Streams gives you the ability to reliably ingest and durably store streaming data at low cost. And you can build custom real-time applications to process that streaming data. So if you take a look here at the diagram across the bottom, we have our data producer. In this case, it shows clickstream data that's being sent to a stream. There's a number of ways to ingest data using Kinesis Streams. All of our SDKs support Kinesis. We have a couple of libraries, open source libraries that you can use as well that give you a lot more efficiencies in how you can produce data and write it to a stream. We have the KPL, the Kinesis Producer Library. We have a Kinesis agent, which is, as it sounds, is an agent that runs in your box and will tail log files and automatically push those records to a stream. So that's the production side. That's one way you can produce data. And then you want to consume the data from the stream. We have a library, again, called the KCL, the Kinesis Client Library. So if you want to write your own application, run it on EC2, pull data out of the stream, and do your own processing, KCL gives you that option. It also supports Lambda. So if you're familiar with AWS Lambda, it's very easy to configure, write your own function in Lambda in Java, Python, or Node, and have it process the stream for you. So Lambda will pull the stream, pull the data out, and then, of course, depending on your business logic and your Lambda function, we'll go downstream from there. We also support other third-party consumers, such as Spark Streaming and Storm. You can create a Spark Streaming application and use Kinesis streams as your ingestion stream. And then all the way downstream, so the last, on the far right of the diagram is ultimately what you're doing with the data as it streams through the system. So that's a quick view of Kinesis streams. One point I would make on this before we go further is it also gives you the ability to scale. So in a Kinesis stream, there is the notion of shards. So a shard gives you a certain throughput. A single shard gives you 1,000 writes per second or 1 megabyte of total ingestion. And so if your use case is more than that, it's very easy. We have an API, or of course we have the AWS console where you can go in and say, I need 10 shards because I want to support 10,000 writes per second through my ingestion stream. And the reason I'm talking about shards now is when we get into Kinesis Analytics, there's some relationship there. So it's important to know a little bit about Kinesis streams and how it's comprised of shards before we go into Kinesis Analytics. So next up, we have Kinesis Firehose. Kinesis Firehose was created, it went generally available last year at reInvent. The most common use case we saw when we announced Kinesis Streams, so just the pure streaming product, was purely loading streaming data into a persistent data store. So data was getting written into streams, and customers were writing their own applications. Maybe it was like a KCL app, that's the library that we've created, to write data into S3, right? And they just wanted S3 to host the static data that was flowing through their stream. That was with Kinesis Streams. We noticed that a lot of customers were doing it. So we decided it'd be great, since so many customers are doing this, if we could just offer this to the customer. You don't have to write your own application. If you could just configure a Kinesis Firehose, have the data flow into it, have the data land in a durable storage location, it'd make your life much easier. No custom code that you have to write. And that's sort of the genesis for Kinesis Firehose. So Kinesis Firehose has Kinesis streams under the covers, but you don't see that as a customer of Kinesis Firehose. You configure Kinesis Firehose. You also configure your destination. So you configure where do you want the data to reside once it is put through the stream. And we have 3 choices for you today. It's S3, Redshift, or Amazon Elasticsearch service. So those are the 3 destinations that you can choose to persist your data as it goes through Kinesis Firehose. And there's no administration that you'll need to do here. It's basically through the API, or most customers in this case, because it's usually a one-time setup, go into the console, configure the Firehose, and you're done. So that's Firehose. Very simple, very common use case for streaming data and durable storage of that streaming data. So that brings us to Kinesis Analytics. So far, we've got the streaming data, either your own custom application to process it, or you're just writing it durably into a storage location like S3 or Elasticsearch or Redshift. But in a real-time streaming data scenario, you want to be able to process that data as it flows through the system. And so that's what Amazon Kinesis Analytics brings to the table. It allows you to interact with that streaming data using SQL. And it's built upon ANSI 2008 standards, supports almost the entire standard, and we've extended it a little bit to support streaming data scenarios. And you can build fully managed elastic stream processing that produce data for real-time visualizations. We'll get into the details of like a few common use cases that we see, but this is what we're here to really talk about today. So let's get a bit deeper into Kinesis Analytics. Just a few sort of bullet points, easy to use. It automatically scales based on the throughput and the amount of data and the amount of processing that the system needs to do to process your data. It's in real time. You pay only for what you use, and I'm going to talk a little bit more about the cost model later. And as I mentioned, standard SQL for analytics. So the reason we chose standard SQL, it's a very common, very popular language, obviously, in many parts of the data analytics world. So it just is natural that we could make that an offering, and many people would be very familiar with it, not have to go learn a new technology. A lot of people in the industry are already familiar with SQL, so it was kind of a natural choice to analyze data using a very common language, SQL. So it's really a three-step process when you create a Kinesis Analytics application. You connect to a streaming source, you write the SQL code to process the data, and then you deliver the results somewhere, which I'll describe in a moment. So connecting to a streaming data source, and that's why it's important to understand, in this case, why Kinesis Streams and Kinesis Firehose, kind of have a good understanding of those before we start, because those are your two sources that you can choose for Kinesis Analytics. So if data is streaming in, if you already have a Kinesis Stream or a Kinesis Firehose, you can today go and create a Kinesis Analytics app and start processing and analyzing that data in real time. If you don't, you can create a Kinesis Stream or Firehose, and Kinesis Analytics can process that. But those are your two input choices. The input types that Kinesis Analytics support are JSON, CSV, or unstructured text. And we can talk a little bit about that as well. But most of the use cases that we see today, customers who are putting data into Streams or Firehose, they're putting in typically JSON or CSV or some delimited structure into their stream. And that makes it pretty simple to create a schema out of it. So because we're writing SQL in Kinesis Analytics to analyze your data, we need to have a schema, right? Select star from table where you need to have a schema to make that work. And so when you connect to a streaming source with Kinesis Analytics, it will create a schema based on your input data. You have some options around that, and we'll get into the details of that, but it's important to realize that a schema is created from your input data. And you can also leverage reference data sources, static data that you might have in S3. You can use that in your application as well to enrich the streaming data in real time. Next step is to write your SQL code. One or more statements. Doesn't have to be a simple select. You can have nested select statements. You can have joins, inner joins, outer joins. Just like I said, the 2008 ANSI SQL standard is supported. And when I talk through the example, I think you'll see kind of a good example of multiple streams of data and using several SQL statements to get the output that you want for your application. And support for at least once processing semantics. So when you write your SQL to process your application, and Kinesis Analytics is going to attempt to deliver that to your destination, if for some reason your destination is unavailable, Kinesis Analytics will continue to try and process that data and get it into your destination so that it's available to you. Cool. And that's where we get into the continuously delivering the SQL results. So you send your processed data to one of two sources, but ultimately because Firehose gives you the three destinations of Redshift, Elasticsearch Service, and S3, you get 4 destinations that you can send your output of Kinesis Analytics into. So you can send it to S3, Redshift, Elasticsearch, or into another stream. So you can send it into another Kinesis stream, so you can then do further analysis downstream if you'd like to. Or if you have, for example, a Lambda function, and you want to take the output of your analytics application, and you want to maybe send like an alert to an operator, you can use a stream with a Lambda function. The Lambda function can then just put a message into SNS, simple notification service, if you're familiar with that, and then that might be able to send an email or a text. So that's a very popular use case for using streams as an output source. You can achieve end-to-end latency as low as a second. I will point out here that the end-to-end processing speed depends on your query. Not so much the complexity of your query, but the aggregation that you're doing. In most use cases in Kinesis Analytics, you're doing some kind of an aggregation over time. You're going to say, tell me the number of records that meet these criteria in 1 minute or 1 hour. So if you do that, and depending on a number of other factors like the windowing, which we're going to get into, you'll have one output per 10 seconds, let's say. So if you want to say, count the number of times something has happened in a 10-second window, every 10 seconds, there will be an output from Kinesis Analytics. And then the nice thing about this is it separates the processing and data delivery. So all the processing being done by Kinesis Analytics is separate from the destination of Kinesis Firehose or Kinesis Streams, and the at least once processing ensures that the data ultimately arrives at your destination. So what are some common use cases for Kinesis Analytics? As I mentioned, Kinesis Analytics went generally available. We announced it last year at reInvent, became available for all customers in August. So it's been in production for about 3 months now, and we're getting a good feel for what customers are using it for. One of the most popular that we're seeing, and this is the demo that I'm going to walk through here momentarily, is just computing key performance indicators over time periods. So you can imagine, let's say it's an e-commerce company, and you want to track what is the most popular product in the last 10 minutes, if it's a very popular website. That would be a good aggregation that you could run here. And you could output it downstream for further analysis or visualization. Feeding real-time dashboards. So similarly, if I have some business metrics that I want to track, and I want them to be available to my business or my operations staff immediately, and I want to make it visually available to them through tools like Kibana or QuickSight, that's a very common use case that we see for Kinesis Analytics, feeding aggregate data into real-time dashboards. And then thirdly, we see a lot of customers using it to create real-time alarms and notifications. So they're building sequences of events. So how many times in a certain period has something happened, and if that's important. So a good example might be Apache access log data. So if you have a large fleet of web servers, maybe you have 20 web servers, and all of them are pushing their Apache access log data through a stream, and you use Kinesis Analytics to do some analysis on that. It's very simple to say, when I get more than 10, 500 HTTP response codes in a brief period of time, I should probably do something about that. And so we have a lot of customers who are now using Kinesis Analytics to do, as an example, Apache access log analysis, and alerting their operations team when they see anomalies in their streaming data. So let's walk through an example. We're going to take a look at some Twitter data, a very common use case. I think if you guys have been through a few different sessions, you have probably seen that Twitter is a nice use case for kind of practicing streaming data. It's a very simple use case to point to. There's lots of data coming through Twitter. And then NHL, so National Hockey League. I am from Canada, so I enjoy hockey. So I thought it would be kind of a neat use case to take a look at some Twitter data related to National Hockey League teams. Here are the requirements for the scenario. First thing we want to do is filter for NHL-related tweets. Twitter is very noisy. If you guys have a Twitter account, you know this already. We want to look at the total number of tweets per hour that contain hashtags for NHL teams, and then the top 5 NHL-related hashtags per hour. So that's sort of the data we want to capture. But the output that we want to send downstream, filtered tweets. We want to get rid of all the ones that aren't relevant to us. We want to do some aggregations. So we want to do an hourly aggregate count and save it to Amazon Elasticsearch. And we want to take the full team name. So the hashtag is usually very short, right? I'll have an example here in a moment, but it's usually 4 or 5 letters. That is the nickname of a team. But it typically doesn't have like the city, right? It might say Rangers, and it means New York Rangers. So what we want to do is have the output actually contain the full team name, and then how many times that team was referenced in an hour over time. So why is Kinesis Analytics good for this solution? A few things. There's a few challenges with this. First of all, like I said, Twitter streams are noisy. A tweet structure is quite complex. If you haven't looked at a tweet, it's JSON, but it's very complicated. It has hundreds of attributes and a lot of different nested layers to that. And also, NHL-related tweet volume is very cyclical, as you can imagine. Certainly on an annual basis it is, but even weekly and hourly it's cyclical. So over a week, weekends are more popular, and then in the given period of a day, certainly in the evenings when actually games are happening, there's a lot more tweets than there are at 6 a.m. So it's a very cyclical use case. So with Kinesis Analytics, we can easily, the reason it's good for this use case, makes it very straightforward with a SQL statement to filter out tweets we don't care about. It makes it very simple to normalize the tweet structure, so that gives us the ability to do SQL on that data. And then it automatically scales. So because of the cyclical nature of this kind of data, we don't want to over-provision for something if it's not going to be used in July, or if it's not going to be used at 6 a.m. So it's a really good use case because Kinesis Analytics will automatically scale based on the data. So this is what we're going to build. This is our end-to-end architecture. If we go from left to right, we've got our Twitter stream. There's an EC2 instance here in the mix. I'll explain that in a moment. Actually, I'll explain it now. If you're not familiar with how you integrate with Twitter, basically, like Twitter is not going to push the data directly to a Kinesis stream. You have to have your own Twitter application in the middle. So basically something that will take the data from Twitter and then do something with it. In our case, the doing something with it is putting it into a Kinesis stream. That's the model with Twitter. Is you create a Kinesis, or sorry, you create a Twitter application that receives the data, the streaming data from Twitter, and then you can do whatever you want with it at that point. So that's the left-hand side. We have the stream as the ingestion, Kinesis stream. Then we have our Kinesis Analytics application and some reference data, which I'll explain in a moment. And then we're going to output that to Firehose and then ultimately S3 and Elasticsearch on the far right of our diagram. So if we kind of take that and we're going to walk through this from left to right. As I mentioned, the source JSON data from Twitter is quite noisy, hundreds of attributes. It's about 5K per tweet, and most attributes we don't care about for this use case. So what the EC2 instance is doing here is when you create a Twitter application, you can't tell Twitter, I want you to just filter out some of this stuff for me already. I don't have to get a full stream of all tweets. I can say, just give me stuff relevant to NHL, NFL, NBA, MLB. I can even give it like the hashtags for teams that I want. So it can give me an already filtered list. And so in this scenario, I'm still getting some dirty data. I've asked for all kinds of sports data. But obviously in my use case, given the criteria for this, I only care about the NHL teams. So I'm still getting some noise. And the EC2 instance here in the middle, it's going to do a bit of filtering. Like that's what it's going to ask for only some limited sets of data. And it's going to also get rid of some of the data that I know I don't care about in my application. So it's doing a bit of filtering up front. And then the Kinesis streams data, so what ultimately lands in our Kinesis stream on the front end of our analytics system is going to be a smaller record because I'm getting rid of the noise. And it's only going to contain some relevant attributes for our use case. So this is an example. If we look at the JSON on the left, this is a tweet. You can see it's pretty basic. I've taken a lot of the noise of data out of it, but it gives me the data that I want. It has the tags, Canes, NHL, has the actual text that the user tweeted, and it has some other couple of other things like the created date and a unique ID that Twitter creates when they get a tweet. And as I mentioned earlier, Kinesis Analytics will attempt automatically to take the input data and map it to a schema. So on the right side of the screen, you see what looks like a table in a relational database. Right? I have a column, I have an ID, a text, a created at, and a tag column. And Kinesis Analytics automatically takes the tag array from the JSON and creates it, and it basically explodes it. So we now have 2 rows in my table, one with each tag, and the rest of the data is the same. So this schema was automatically created by Kinesis Analytics the first time it inspected the ingestion stream and noticed the schema of the source, and then it created this schema so that I can now use it in my application. When we talk about best practices in a few moments, there are some things to note about the automatic schema creation. The short answer is don't blindly trust what Kinesis Analytics creates. I'll get into why that is. But it does make a really good first pass, but you need to make sure that you've inspected it and you make sure that you change it to be relevant for your data. A lot of times if your data comes in and Kinesis Analytics looks at a sample of the data to create the schema, if for some reason one of the attributes didn't exist, then it won't put that in your schema. But if you want that attribute to be converted into a column in your schema, then you need to go in and manually change the schema. So that's the best practice. I got ahead. But anyway, now you know. All right, so before we get into the specifics of the streaming data, how we're going to implement this, there are a few constructs. And as I mentioned earlier, we support ANSI 2008 SQL, but we had to extend it to support streaming data. So there's 2 constructs that are important. One is called a stream, and one is called a pump. With a stream, it's important, and I don't want to confuse you because it's important to realize this is not the same as a Kinesis stream. It's unfortunate that they have the same word, but when I talk about Kinesis analytics, I'm going to talk a lot about in-application streams. And this is only contextually relevant inside of the Kinesis Analytics app. It's not at all related to the Kinesis stream from which your data is being sourced. So just keep that in mind. A stream, it's analogous to a table. So if you're familiar with relational databases, of course you have tables. You're going to write your queries against those tables. A stream is very similar. So if you look at this first statement here, create or replace stream, NHL tweet stream, you see that it looks like I'm creating a table. Right? If I was to say create table, I would give it a schema. This is very similar. I'm creating an in-application stream in my Kinesis Analytics app, and this is what the data structure is going to look like in that stream. But because it's a stream, it's not static data. Right? If you have a table in a relational database, it's generally static. Of course, you can do inserts and updates, but it's generally static. The difference being with Kinesis Analytics, the stream is always changing. I've got data flowing through my system, and I need to figure out how do I populate that table or that stream with data that's always changing, and that's what a pump does. It's essentially running a continuous insert query into your stream. So if you look at the bottom, create or replace pump, and then it has insert into. So your insert into statement here would be essentially running continuously to ensure that your stream always has a flow of data going through it. So those two constructs are important as we kind of get into the rest of the requirements and how we solve that problem. So how do we model our data, right? We have these boxes. As I mentioned, streams are very similar to tables. So you can think of these like tables in a relational database, and you can join on them. You can select. You can even do inserts via the pump. But if you were to model this kind of a solution using a relational database, it might look something like this if these were your tables. The difference being these little green arrows, these are the pumps. So I have a SQL statement that's continuously being executed, selecting and inserting data into my NHL tweet stream. So the source stream on the left, this is what gets created based on the data coming in from Twitter. It's my raw data. And then I have subsequent streams downstream from that I can then use SQL to query and get my aggregated metrics. So let's take a look at the top one. So how do we filter for unwanted tweets, right? That was one of the requirements. I want to get rid of the stuff that I don't care about. So I'm going to create a pump. And I'm going to insert into the NHL tweet stream some data. That data is very simple, right? I'm going to select data from my source where I don't want NFL, MLB, and NBA. So if I remember correctly, I'm still getting some noise out of Twitter, getting all those hockey team tweets, but I'm also getting some stuff I don't care about because I'm in my filter to Twitter. I said, also give me stuff that has NFL in it. Also give me stuff that has MLB. But for this particular use case, I don't want that data. So it's very easy. Now the stream called NHL tweet stream does not contain any of that data. It just drops it. It's gone in this use case. You can, of course, have another query if you wanted that data and put it somewhere else. You could have another SQL statement that would do that for you. But in our use case, we don't want that data, so it's gone. So my stream just contains now relevant data. So simple as that, pretty simple. I've now got basic SQL doing a where clause, getting rid of the data I don't want. So now my NHL tweet stream, which is like now my new source for the rest of the application, contains only relevant tweets. But as I mentioned, the data that we're looking at only has the hashtag. I want the team name. So if you look at the little table here on the bottom, you can see it's a map, right? I've got the hashtag on the left and then the team name on the right, comma separated. So NY Rangers means New York Rangers. NYR also means New York Rangers, all the way down to Oilers, Edmonton Oilers, and Sharks, San Jose Sharks. So pretty basic. I created a file in S3 that contains all the teams in the NHL and contains the mapping of all the official hashtags that the teams support. And that's stored in S3. So I created a CSV, I stored it in S3, and I configured Kinesis Analytics to use that as a reference data source. And then to get the team name, it's as simple as just doing an inner join between my streaming data that contains the hashtag and the reference data, which contains, of course, the hashtag and also the full team name. So on the left here, you'll see team name, that's a table that gets created in Kinesis Analytics once you tell it where the location of your static data is. So team name is a table, contains 2 columns, hashtag and team, and then the NHL tweet stream is the data, the filtered data that's gotten only the NHL-related tweets. And you can see my SQL statement here. This is basically, we're going to see where this select statement goes. Like I said, it's to get continuous streaming data, you need a pump. We also have some other functions. I'm going to get to that in a moment. But the purpose of this call out here is you can see how simple it is to do an inner join. And my output now of this query is just the team names. Right? I've got now New York Rangers, Carolina Hurricanes, Oilers, Sharks. So all that query did is do an inner join between my static data and my streaming data. And now I can use that data, the data on the right, the full team name, elsewhere in my application. Now we want to do aggregations. How do I aggregate streaming data? It's very common to do analytics. You know, we want to do counts, averages, maximum, extremely common analytics use cases. But I can't simply aggregate over an entire table like you can in a relational or a static data set. Streaming data, remember, I could have this application running for days or for weeks. And so if I said select star from my stream where some value equals 5, in fact, it won't let you. Kinesis Analytics will say you can't do that because the stream is potentially infinite. Right? We need some way to tell Kinesis Analytics how do I do just a subset of my streaming data. I only care about the data in this 1-hour chunk or this 10-minute chunk, and that's through windowing functions. So we'll take an aside and quickly talk about windowing functions in Kinesis Analytics. They're important, and we're going to use them in our problem solution here. There's 2 types. We have tumbling and sliding. They're fixed length. And in the case of a tumbling scenario, there'll be one record at the output of that window that contains all of the aggregate data for that time period. So a tumbling window, when you define a tumbling window and you say, I want my window to be 1 minute, every 1 minute, Kinesis Analytics is going to run your aggregate functions that you've defined in your SQL, and it's going to output a record. So let's say you have no data coming through your stream, but your function is using a tumbling window, and your window size is a minute. Every 1 minute, there'll be an output, but your aggregate will be 0. Right? I've got no data. It's still going to do a count, but there's going to be no records, so there'll be 0. So that's the example of a tumbling window. At the end of every window, there is a result set, regardless of data or not. And inside of that window, if you do have data, of course, it'll run your aggregation, and it'll give you a result. With a sliding window, it's slightly different. Sliding windows, the window starts when the record arrives. So if I have, again, a 1-minute window, a record arrives, Kinesis Analytics will now, based on the timestamp of that arriving record, it will run the aggregation for all the records that had arrived in the minute previous to that record, including, of course, the current record. And now, let's say 1 second later, another record arrives. Kinesis Analytics will run another analysis, and it will include that record, and it'll look at all the records that arrived in 1 minute previous to that record arriving, and it'll do the aggregation and give you an output. So in that latter scenario with a sliding window, I actually have 2 outputs from Kinesis Analytics 1 second apart, but they're still 1-minute aggregations. They're just 1 minute aggregations based on the time that the record arrived, versus a tumbling window, which is just every 1 minute, give me an output. So those are the 2 differences between a tumbling window and a sliding window. And in our scenario, we're just counting those records based on a 1-hour tumbling window. So how do we aggregate these team mentions per hour? Amazon Kinesis Analytics supports a number of built-in functions that make some analysis much simpler than you could do just by writing the SQL. You can always write the SQL to do things like distinct counts or top number of items in a window, but we've created a few functions for common use cases like top K items tumbling. So it's a function that you can use in your application to do a basic count. It's more efficient, essentially, than doing it on your own in SQL. So we've created a few of these functions to make that easier for you. And then how this function in particular works is you give it a cursor to a stream, And then you provided a couple of parameters. You say, here are the number of items I want you to count, and then here's the window size. And so in this case, I'm actually giving it a cursor to a stream. That stream just happens to be that stream that I created earlier that has all the team names. So the full team name stream that I created a moment ago is input into this. It's passed as a reference with a cursor. And then top K items tumbling every 1 hour will tell me the top 5 mentions, top 5 teams that were included in that stream. And it'll tell me how many times they were also mentioned. So it's going to do that count for me. And it's going to give me the output every hour because it's a tumbling window. And lastly, we're going to output that data to Amazon Kinesis Firehose. So Firehose, like I mentioned, gives you the option to put data into a number of different locations. And in this case, we're putting it into Elasticsearch so that we can kind of visualize the team data. So every hour, because my function, aggregation function, was giving me the top 5 mentions, top 5 teams that were mentioned, every hour I'm going to have 5 records. Each record is going to look very similar to this, right? I've got a time, that's my aggregation time. So that's the end of my 1 hour window. And then I have the full team name. So the input, recall, was the hashtag NYR, but that's not very useful to me in my use case. I want the team name. So on the output, I send the full team name, and then I have my aggregation. And so there'd be 5 of these records every hour, 1 for each team, going into Firehose. Firehose has a few features for buffering. The minimum amount of time that you can buffer with Firehose is 1 minute. So in this scenario, I would just buffer. And because my aggregation is an hour, the buffer size here can be a minute or 5 minutes. It's not that important. Amazon Firehose will once a minute, if I've configured it that way, put my records into Elasticsearch, and then I can visualize it using Kibana. So if you're not familiar with Elasticsearch service, it has Kibana built in natively as well. So for things like visualization, that's why they're kind of wrapped in one single box here. It's very straightforward. Kibana is a nice tool for visualizing data in Elasticsearch, and our Elasticsearch service has native support for Kibana. It's just 1 click, and you have a Kibana implementation. So that's the output, and then we want to visualize it. So it was very simple. I went into Kibana, just said, show me all the data over a 24-hour period of all the teams and how many mentions there were. And you can see the chart that I've got here. And the team, it's maybe hard to make out. Chicago Blackhawks had 2,500 mentions. What's kind of neat about this solution, this scenario, was obviously, it gives you good insight into who was playing. So I took this data, I kind of correlated it with the actual schedule, and not surprisingly, where you see these peaks was when these teams were playing. So it gives you some kind of good insight into what was going on in the league at that period of time, who was playing, who was winning, actually. So it was kind of a nice insight into that. So that's a quick overview of Kinesis Analytics, kind of one use case for how you can simply aggregate data and put it into a persistent data source and then visualize that data. So if you recall, the three of the most common use cases that I've seen in Kinesis Analytics usage were, one of them was dashboarding. And so this is a good example of that. I'm collecting some business metrics. In this case, it's mentions, team mentions. And I'm visualizing them in real time in a dashboard. So that's one of the most common use cases that we see today. So Amazon Kinesis Analytics best practices. Like I said, at reInvent, you're here to kind of learn how you can do it, and then what should you consider when you're implementing something. So let's take a look at a few best practices for Kinesis Analytics. As with pretty much everything in AWS, CloudWatch alarms are very important, right? We are writing metrics about your application into CloudWatch. And you should, and regardless of whether it's Kinesis Analytics or some other system, you should monitor those metrics and make decisions based on the data that you see. No difference with Kinesis Analytics. The most important metric, we have a few others, but the most important one you should track is millis behind latest. What that is it tells you how far behind your Kinesis Analytics application is in processing a stream relative to the most recent record added to the stream. So if you get to about an hour behind, it's totally a rough guidance. It's really going to be dependent upon your tolerance for latency and your use case. But an hour, that's a rough kind of rule of thumb. If you get over an hour, there's probably something wrong, and you should consider investigating that. In your use case, you might decide that a minute latency is too long, and so you should do something about that as well. But where you will get that data is the millis behind latest metric. So that is a very important metric to monitor. So what happens if you do see that happening, right? If you do start to fall behind processing your ingestion stream, your Kinesis stream, what do? One approach is to increase the input parallelism to improve the performance. So the reason I talked earlier about shards in a Kinesis stream is because with Kinesis Analytics, when you create an application, it'll go look at your input stream. It'll notice the number of shards. But by default, it'll map all of those into one single in-application stream. Remember, that's a Kinesis Analytics construct, an in-app stream. So you now have one stream in Kinesis Analytics containing the data from all of your input shards. If you notice yourself getting perhaps behind, one approach is to create additional, there's basically a feature in Kinesis Analytics that allows you to create more in-application streams for the number of shards in your input Kinesis stream. So it gets a little complicated with all those streams. But what you want to do is take a look at the parallelism attribute associated with your Kinesis Analytics app and increase it. Let's say you have 4 shards and you create Kinesis Analytics parallelism attribute set to 4. Now you'll have 4 in-application streams in your Kinesis Analytics app, 1 for each shard. You probably have to go in and change your SQL because now you've got 4 different in-app streams, 1 containing each shard. You're probably going to have to do a little bit of aggregation to put them into a single in-application stream in the Kinesis Analytics app. But now you've got some parallel processing that you can do. And so if you find the millis behind latest metric falling behind, take a look at the parallelism feature that you can adjust in your Kinesis Analytics app. Limit the number of applications reading from the same source. So this isn't necessarily a limitation of Kinesis Analytics, but if you're familiar, or even if you're not familiar with Kinesis Streams or Kinesis Firehose, Kinesis Streams has egress limits. 5 transactions per second can come out of a Kinesis stream, or 2 megabytes per second can come out of a Kinesis stream. So if you have a Kinesis Analytics app that you've written to do analysis on the data in that stream, you need to consider that Kinesis Analytics app is just another consumer of that stream. So because that stream only supports 5 TPS or 2 megs egress, if you were to put 10 Kinesis Analytics applications all reading from the same stream, you would go beyond the 5 reads per second because Kinesis Analytics is actually reading once a second from your stream. So if you go over 5, and in fact, if you go even less than that, but if you go to 5, you're going to be throttled by the Kinesis stream. So you want to make sure that you don't go over 2 to be on the safe side. And then Kinesis Firehose, very similarly, because like I said earlier, Kinesis Firehose is ultimately writing your data to a destination, whether that's S3 or Elasticsearch. That's one consumer already, right? So we don't want to impact the system that's already writing data to S3. So with Kinesis Analytics, if using Firehose as a source, you should limit it just to one Kinesis Analytics app reading from that Firehose stream. Same thing, you don't want to get the read provision throughput exceeded exception being thrown by your source Firehose or your source Kinesis stream. I kind of talked about this already, but review and test that inferred schema. Like I said, Kinesis Analytics is going to look at that input data. It's going to create a schema, but it's only looking at a sample of your input. So if your data didn't contain every single attribute in the sample set that Kinesis Analytics used, your schema is not going to match. If let's say your input type was a text and it was a string of, let's say, maximum size it could ever be is 200 characters, but the sample records that Kinesis Analytics looked at never had a text size greater than 50 characters, it's going to create a varchar 50 as the input data type. And so as soon as you get to like a string that's 100 characters, it's going to truncate that, and it's not going to be useful to you. So you need to be aware of what your input data looks like. Go in and modify the schema, because the inferred schema is like our best guess. But you know best based on your use case. Yeah, OK. The last point here, sorry. So using SQL functions in your application for unstructured data. So it's possible if you have very unstructured data and Kinesis Analytics could not create an inferred schema from it. Doesn't mean you can't use Kinesis Analytics, but there are plenty of string manipulation functions that you could use inside of your Kinesis Analytics app to do the parsing of your data and then do additional analysis after you've parsed it in your application. When you're writing your application code, try to avoid time-based windows greater than an hour. I know my example used an hour. That's the most that we'd probably want to go. The reason being, if for some reason, like let's say you went in and you stopped the Kinesis Analytics app, or something happened in Kinesis Analytics and it stopped processing your application, it's going to go back and reprocess the data. It's checkpointing where it last left off. So if your time windows are large, let's say longer than an hour, when it comes back up, it's going to go back and it's going to process the data. And depending on your application, it might have a hard time getting caught up, so that millis behind latest might continue to be kind of out of the threshold that you've set. So try and keep your time-based windows shorter. And in fact, kind of another point is, if you're talking about longer than an hour aggregations, it's no longer like real-time streaming data. There might be other solutions that are better for doing that kind of analysis. When you're building your application, this is kind of a no-brainer, but keep your window sizes small. When I was developing that NHL one, I used like 10-second aggregations. It just makes it easier to see what's going on. If you have to wait an hour to see the output of your results because your business asked you to give you an hourly result, it's going to take you forever to develop the app. So just create like 5-second, 10-second windows. Gives you a lot more visibility. And similarly, the last one, this is kind of best practices in just development. Think of it like microservice development. Use smaller queries. So instead of creating one large SQL query with a whole bunch of nested SQL in your application, because you can create in-application streams, create more smaller streams, because you can inspect the output of these smaller streams. So you can create several select statements, and then you can inspect them in your application in the Kinesis Analytics app. It's going to be much easier to debug your application. There's a few limits. If you've used AWS for a while, most of our services have limits. Some are soft, some are hard. In this case, these are all fixed limits. These can't be changed. But every row size in an in-application stream, maximum size is 50K. Maximum input parallelism, I talked about that. Having the ability to change the input parallelism is 10. So you can have 10 in-application streams based on your input data. And then we talked about this as well, but each application can support one streaming source and one reference data source. So you can connect to either Kinesis Stream or Kinesis Firehose, and you can use some reference data from S3 in your application. The last point here too, your reference data can't be larger than 1 gig. 1 gig is the max size. And that brings us to the last point that we'll talk about here, and then I think we'll have a couple of minutes for questions. But pricing, and then tied to pricing is this notion of KPU, or the Kinesis Processing Unit. So with Kinesis Analytics, you pay only for what you use, but you're charged based on an Amazon Kinesis Processing Unit. So what does that mean? A KPU is a single vCPU and 4 gigs of RAM. So as your application is running, of course, we are monitoring it, and we know how much CPU and memory is required to process your data and give you the results in the time that you're expecting. So if you're doing a 10-minute aggregation, we want after the 10 minutes, we want that to go downstream nearly immediately after that 10-minute window. So we will scale accordingly to do that. We'll add virtual CPUs and we'll add memory up to 8 KPUs. So the max you can consume at any point in time is 8 CPUs or 32 gigs of RAM on the hosts that are managing the application. And you're charged this is in US East. The prices are, of course, dependent on the region, but in the US East, 11 cents per KPU hour. So for every hour that your application is running, if it is only consuming one KPU, then you're paying 11 cents an hour. Of course, with the example that I described, the Twitter analysis, keeping in mind that there's some cyclical nature to that. You know, it might, at night on a Saturday, it bursted up to like 2 vCPUs and 8 gigs of RAM. And so for the couple of hours when that was happening, I might have paid 22 cents an hour because it's 2 KPUs. And then when it goes back down overnight, it automatically scales back down, and you're only paying the 11 cents an hour. So it's based on the KPUs is how you pay for Kinesis Analytics. So that's a introduction, I hope, to Kinesis Analytics. Gives you kind of a good idea of some of the common use cases that we're seeing today. Walks through an example. I hope that gave you some insights into perhaps how you can leverage Kinesis Analytics in your application with your business data. So that's it. Thank you very much. We do have 4 minutes. I can probably take 2 questions.